Intricate Devo. Intricate.
Hello everyone, and welcome back to Intricate Devo, where complex programming concepts become simple, practical, and fun to learn. Today we're exploring a small Java keyword that has a huge impact on object-oriented programming. That keyword is super. Now, at first glance, the word super sounds like a superhero. And honestly, that's not far from the truth. Because whenever a child class needs help from its parent class, the super keyword comes to the rescue. But before we jump in, take a second to support the channel. Like this video. Comment Super Java below. Share this video with a friend learning Java. And subscribe to Intricate Devo for more beginner-friendly programming tutorials. Alright, let's get started. What is the super keyword? Imagine you're a teenager asking your parent for help. Maybe you need your parent's car. Maybe you need some advice. Or maybe you need access to something that belongs to your parent. In Java, the super keyword works in a very similar way. It allows a child class to access things that belong to its parent class. Think of super as a direct phone line connecting a child class to its immediate parent class. Whenever a child class wants to talk to its parent, it uses the super keyword. Simple. Boot extremely powerful. Why does super exist? Whenever you create an object of a child class, Java automatically creates the parent class part of that object as well. Many beginners don't realize this. For example, if car extends vehicle and you create a car object, Java first creates the vehicle portion and then the car portion. The super keyword gives us access to that parent part of the object. And Java allows us to use super in three major ways. First, to call a parent constructor. Second, to call a parent method. Third, to access a parent variable. Let's look at each one. Use number 1, calling the parent constructor. This is the most common use of super. Imagine you're building a car class that inherits from a vehicle class. The vehicle class stores a brand name. The car class stores a model name. When we create a car object, we need both pieces of information. The brand belongs to vehicle. The model belongs to car. So how do we initialize the vehicle part? That's where super comes in. On the screen, notice the constructor inside the car class. Instead of directly assigning the brand value, we use super brand. This tells Java, hey, parent class, you handle the brand information. Java then calls the vehicle constructor and properly initializes the vehicle portion of the object. Then the car constructor continues its own work. This is why when a car object is created, both constructors execute. First vehicle, then car. Think of it like building a house. The foundation must be built before the upper floors. Similarly, the parent constructor runs before the child constructor. And here's an important interview question. The call to super must always be the very first statement inside the child constructor. Not second. Not third. Always first. Otherwise, Java will refuse to compile the code. Quick checkpoint. If you're following along so far, comment constructor mastered below. Let's continue. Use number 2, calling a parent method. Now let's imagine an animal class. The animal class has a method called eat. It simply prints, this animal eats food. Now we create a dog class. Dogs are animals, so dog extends animal. But dogs have more specific behavior. Maybe we want the dog class to print, this dog eats dog food. Easy. We can override the eat method. But what if we still want the original animal behavior too? That's where super helps again. Inside the dog class we can write super eat. This tells Java, before running the dog version, run the parent version first. The result becomes, this animal eats food, followed by, this dog eats dog food. Instead of completely replacing the parent behavior, we extend it. And that's one of the best uses of super. Use number 3, accessing a parent variable. Now let's look at a situation that confuses many beginners. Imagine the parent class has a variable called speed. The value is 50. Now the child class also creates a variable named speed. But this time the value is 100. Which speed variable will Java use? The answer is the child variable wins. The child variable hides the parent variable. This is called variable shadowing. Now suppose we want both values. We can use tis.speed to access the child version and super.speed to access the parent version. Imagine two people in a house with the same name. Using super is like saying, no, I want the parent version. That's exactly what Java does. Real life example. Let's use a real world analogy. Imagine you're driving a car. The vehicle class knows the brand. The car class knows the model. When someone asks, what car do you drive? The model comes from the child class. But when someone asks, what brand is it? The answer comes from the parent class. The super keyword helps the child access information stored in the parent. Simple, logical, powerful, advanced super with interfaces. Now here's something many developers discover later in their Java journey. Since Java 8, interfaces can contain default methods. But what happens if two interfaces contain the same default method? Java gets confused. This situation is similar to the famous diamond problem. To solve it, Java forces us to choose which interface implementation we want. And we can do that using special syntax. Interface.super.method name. This explicitly tells Java which interface method should run. You won't use this every day as a beginner. But it's a great concept to know as you grow into advanced Java development. Common mistakes. Let's quickly cover some mistakes beginners make. Mistake number 1. Forgetting that super must be the first statement in a constructor. Mistake number 2. Using super when no inheritance relationship exists. Mistake number 3. Thinking super can access grandparents directly. It cannot. Super only talks to the immediate parent class. Not grandparents. Not great-grandparents. Only the direct parent. Why should you CRE? Because super is used everywhere in real-world Java applications. Spring Boot applications. Enterprise software. Android development. Game development. And large-scale back-end systems. Whenever developers extend existing classes, the super keyword becomes an essential tool. Understanding it now will save you countless hours later. Quick recap, let's summarize everything. Super refers to the immediate parent class. Super calls a parent constructor. Super.method name calls a parent method. Super.variable name access a parent variable. Super must be the first statement inside a constructor. Super only works with direct para class. It helps extend parent behavior instead of replacing it. Comment challenge before you leave. Here's today's challenge. Suppose a parent class contains a variable called speed with a value of 50. The child class also contains a variable called speed with a value of 100. What will be printed if we use tis.speed and super.speed? Comment your answer below. I'll be reading and replying to your responses. OUTRO. And there you have it. The Java super keyword explained simply. If inheritance creates the relationship between parent and child classes, then super is the bridge that allows them to communicate. And once you understand that idea, everything else starts making sense. If this lesson helped you understand super, please support the channel. Like this video. Comment super mastered below. Share this video with your friends and classmates. Subscribe to Intricate Devo and turn on notifications for more Java tutorials. Thank you for watching. Keep learning, keep building, and keep coding like a pro. I'll see you in the next video.